you've probably heard people talk about feedback loops, so let's sort of explain that. As the warming has definitively arrived, we've learned about a number of cascading feedback loops, or reactions to heating that cause more heating to occur more quickly. Some of these include bigger clouds filled with more moisture, trapping more heat. This is because water vapor is actually a greenhouse gas. Sorry, just a second. Can people still hear me all right?
Yeah.
Another feedback loop that we've discovered is that ice melting lowers the planet's ability to reflect sunlight. So light colors like ice white reflect heat, while dark colors like ocean blue or rock gray actually absorb it. There's also thawing permafrost, which releases more greenhouse gases. And Arctic permafrost actually has twice as much carbon as is already in the atmosphere, and that permafrost is melting now. Forest fires also add something to the atmosphere called black carbon, which is made of solid particles that capture heat, and then settle on the ground as black ash, again blanketing the ground in a dark color that absorbs more heat. Every forest that is burned, and maybe I'll go back to this image now. Every forest that is burned is also lost as a carbon sink, or a reservoir of carbon that stores carbon out of the atmosphere while slowly drawing more out and storing it underground. Every time that we burn a forest, we lose all of that, and we release all that carbon back to the atmosphere. All of this together is why scientists fear we are approaching, if we have not already crossed, certain key tipping points, which you probably also heard, where the climate no longer needs our input to continue warming to catastrophic levels. The science writer Elizabeth Colbert writes about this as the tremendous inertia of the climate system. She uses an analogy of a rowboat, which will tip back and forth, returning to its stable position until you push it too far, at which point it finds its other stable position upside down. This is what scientists are referring to when they talk about having X number of years before it's, quote, too late. So let's go back to the timeline. In 1993, on Earth Day, the newly elected President Clinton says, "Unless we act now, we face a future in which the sun may scorch us, not warm us, where the change of season may take on a dreadful new meaning." He promises to reduce greenhouse gas emissions back to 1990 levels by the year 2000. In 1997, the Byrd-Hagel Resolution, which refuses participation in the Kyoto Protocol, passes in the Senate 95-0. Senators argued that they wouldn't sign because the developing world got off too easy in negotiations. In the year 2000, again on Earth Day, President Clinton makes a similar speech. "Scientists tell us that the 1990s were the hottest decade of the entire millennium," he says. As he leaves office, CO2 emissions are up 15% from 1990 levels. That same year, in 2000, geologist Paul Crutzen coins the term Anthropocene, a new era in which human beings are the defining geological force. In the year 2003, a heat wave in Europe kills 70,000 people. In the year 2005, Tony Blair, leading up to the G8 summit, calls climate change, quote, "a challenge so far-reaching in its impact and irreversible in its destructive power that it alters radically human existence." The final statement released from the summit expresses concerns for the issue, but focuses on uncertainty. The report is overshadowed in the media by the London subway bombings. In the year 2014, NASA announces that accelerating melting in the Amundsen sea sectors of the West Antarctic ice sheet have crossed a tipping point, and that 10 to 16 feet of sea level rise has become inevitable. This same year, as Syrian refugees flee the civil war, which many have referred to as the first climate war, the European Union replaces its Mediterranean search and rescue operation, Mare Nostrum, with a border security program called Operation Triton. The following year, the death toll in the Mediterranean is 18 times higher. In the year 2015, the Internal Displacement Monitoring Center reports that extreme weather linked to climate change displaced 19.2 million people across 113 countries, more than twice the number who were fleeing conflict and violence. In 2017, 15,000 scientists from 184 countries issue what they called a warning to humanity, which describes everything from the decline in fresh water per person to the spread of anaerobic dead zones in the world's seas. As a result, the scientists predict we face, quote, widespread misery and catastrophic biodiversity loss. Soon, they added, it will be too late to shift course away from our failing trajectory. In 2018, the IPCC released a special report on what the world will look like at 1.5 degrees of warming above pre-industrial levels. This was at the request of small Pacific Island states, many of which had been told their nations would almost certainly be underwater at 1.5 degrees, and had protested the commonly accepted 2-degree goal. The report showed that much of what is feared for a 2-degree world is still catastrophic at 1.5 degrees. It emphasizes how much less catastrophic 1.5 is than 2, and suggests that pathways for staying below 1.5 degrees are still possible, though they require that we reach net zero by 2050. And even then, each pathway counts on CO2 removal technologies that do not yet exist. So I want to take a look at one of these images from the report, from that 1.5 report. So this is the graph that the IPCC gave to represent what emissions would have to look like for us to stay below 1.5 degrees. Again, all of these pathways, any pathway that they suggested that would be able to stay below 1.5 degrees relies on carbon dioxide removal technology that does not exist. So as I mentioned, I haven't used many slides in this presentation, and that's because I really want a few images to stick with you, and this is one of them. So let me say something real quick also about how we conceptualize this. We talk about wanting to reduce carbon emissions as if that will slow down the rise in temperature, but this is not how it works. Elizabeth Colbert uses an analogy to explain how emissions work that I think is helpful here. Imagine that we're driving a car. Emissions are not the speed of the car, they are how hard we're pressing on the accelerator. Any amount of emissions continue that acceleration, and there are no brakes. In short, we are trying to invent brakes while we haven't seriously considered taking our foot off the gas yet. So this brings us more or less to now, to this year. And this is the part that I really want to emphasize more than anything else tonight. Because as I mentioned earlier, I wrote about the way that basic facts of global warming were misrepresented for decades. But this is what's being misrepresented right now. The true scope of the challenge that we face. Almost nowhere do you see it plainly laid out. In September, basically all major scientific organizations that do climate research of any kind, from the World Meteorological Organization to the IPCC and others, came together to produce a report called United in Science to inform the recent climate summit at the UN. It gives facts on where we need to be and how much we would need to do to get there. So here are a few of the things that it says. The period from 2015 to 2019 is on track to be the warmest of any equivalent period on record, and it's 0.2 degrees Celsius warmer than just the period 2011 to 2015. There's a growing recognition that climate impacts are hitting harder and sooner than climate assessments indicated even 1 decade ago. The new energy available from renewable energy sources each year continues to be outpaced by the yearly increase in overall demand for energy, and so emissions continue to rise. In fact, we are now emitting more carbon than ever, faster than ever, and we continue to accelerate emissions. The current level of CO2 is unprecedented in the past 3 million years. So let's talk about that last detail for a second. We've already traveled back in time a little bit, but now I want to go way back to what those numbers are referencing. You've probably heard someone say that we're entering the 6th mass extinction. Maybe you thought they were being dramatic. Well, in the geological record, we can see that there have been 5 mass extinctions on Earth before. All but one were caused by climate change from the release of greenhouse gases and were accelerated when methane reserves were released from melting permafrost. All of that has happened right now. During the Permian extinction, which killed most of life on Earth, carbon dioxide was being added to the atmosphere at about 1/10 the current rate. To our knowledge, carbon has never been added to the atmosphere at a faster rate than right now. The last time atmospheric carbon was at our current level, sea levels were 300 feet higher. The impacts that this will have, the impacts that this will have on the Earth operate on timescales that are enormous. Some people have even called them religious, and they're often underrepresented in public discussions. This is the same image here, so the Keeling curve that we looked at earlier. This is from just the period of time since the Industrial Revolution, or a little before that we're watching. So this same data graphed over a much longer period of time is right here. So that very last little bit is how much that rise represents on a longer time scale.
Nathan, I'm sorry, can you read the green dates on the bottom? Like what are the
Yeah, I'm sorry. So this is over this is thousands of years. And so it's 800,000 years is the farthest back. So over the course of 800,000 years, you can see what the fluctuation in temperatures has been. And then in just this last blink of an eye here, how much things have changed. Temperatures have been lower frequently, but never have been higher than that right now in that period of time. So just to give some idea of what these timescales are like, if we were to stop emitting right now, it's estimated that 75% of global warming's effects would persist until 500 years from now. If we were to go forward 30,000 years from now, ocean currents will have absorbed more of the carbon compounds, but 25% will still hang around in the atmosphere. By way of comparison, the paintings in the Chauvet cave in France, which I have some pictures of, the earliest known examples of human art date back 30,000 years, just to give you some idea of how long of a period of time we're talking about. And 100,000 years from now, 7% of global warming's effects will still be occurring, as igneous rocks slowly absorb the last of the greenhouse gases. We're tampering with something that we do not, and that frankly we cannot comprehend. For this reason and others, I'm not going to get into the predictions for the future tonight. There are a lot of books on these predictions, you can look them up, and they read like science fiction. There's so many factors that people find it difficult to conceive of what might come.